explain how the spirometer works. So if you imagine an enclosed area, an enclosed kind of vessel that contains air. Within that air, you've got some oxygen, I've coloured those in red, and you've got some carbon dioxide. Now, obviously, it's about 20% 20% oxygen and about 0.04% carbon dioxide. So there's a lot more oxygen than there is carbon dioxide. Now, obviously, if you were just breathe in and out of here, the volume wouldn't change, but the composition would. So as you breathe out, you would take some air out of here. Now, you would be absorbing some of this oxygen. So when you breathe back out, some of that oxygen has gone, but you've replaced it with carbon dioxide. So we've got rid of 3 oxygens. You would replace it with 3 carbon dioxide. The carbon dioxide you breathe out is equivalent to the oxygen that you breathe in. Okay? So the volume wouldn't actually change, but the composition would. So if you just looked at a trace of lung volumes, obviously when you breathe in, your lung volume is going to increase, and when you breathe out, your lung volume will decrease. If you breathe in, your lung volume increases and your lung volume decreases. On a spirometer, you're taking air out of a tank. Okay? So you've got a tank of air, which is here. So this is air, and this is sitting on a bed of water. Okay? And then you've got a tube that's coming from the person who's breathing to the air tank. Now, if you take air out of here, the volume here will decrease, and so this water level would kind of increase, or what would happen is this tank would actually decrease. And if you had a pen attached to it, when you breathe in and take air out of here, it lowers in the water, and so your spirometer trace would go down when you breathe in. This pen, if this was a nice sharp pen, would actually go down as you breathe in. When you breathe back into, when the person breathes out and breathes back into this tank, you're putting more air back into here, and that's going to raise it up, and so your spirometer trace will go back up because this pen would now go back up. So whenever you breathe in from a spirometer, you're taking air out of this tank, and so this tank will sink in the water. And every time you breathe back into this, when you breathe out, you're putting air back into this tank, and the tank will raise. It's like inflating and deflating a balloon. So if you think of this tank of air as a balloon, when you breathe in, when you suck air out of that balloon, the balloon will go down, and so your trace will go down. When you blow out into the balloon will go up, and so your pen would go up and your trace will go up. So for a spirometer, when you breathe in, it goes down, and when you breathe out, it goes up. Whereas obviously if you're just looking at lung volume, how much air is in your lungs, when you breathe in, the spirometer trace goes down, but if you look at your lung increases in volume. When you breathe in, the spirometer trace goes down, but your lung volume goes up. And equally, when you breathe out, your lung volume decreases, but the spirometer trace, because you're putting that air back into the spirometer, your spirometer trace goes back up. So they're kind of showing the opposite of each other, because obviously one is the volume in your lung, the other is actually indicative of what's happening here. So if you breathe in, you're taking air out of here. So there's less air in there, so it goes down. When you breathe out, you're breathing out out of your lungs, and so you're breathing air out. So your lung volume goes down, but you're breathing that air back into that tank. So the air in the tank is going back up. Okay, so when you breathe in, you're taking air out of the tank. When you breathe out, you're putting air back into the tank. Okay, so normally your trace would just go up and down. Whether it was a spirometer trace or a lung volume trace, your trace would just go up and down, showing the normal kind of quiet breath, the normal ebb and flow of your breath. Now, spirometer traces we can use to determine how much oxygen you've consumed. Now, a spirometer trace over time will go down. And that is because, yes, you're taking air out, you're absorbing the oxygen, and you're breathing back out, and so you're going to change the composition. So what you're breathing out has less oxygen, but more carbon dioxide. And so actually, if you just breathed in and out into a tube, the volume wouldn't change, but you'd have more carbon dioxide and less oxygen. Now, let's just reset this. So if we put those oxygens back in for a minute. Okay, so imagine you take a nice big lungful. So you're taking air out of here. Okay? Now, when you breathe in, you're not breathing, when you breathe back out, you're not breathing out that oxygen because you absorbed it from your lungs into your blood. That oxygen from that tank has now gone into your blood, off it goes. When you breathe out, some of that carbon dioxide that you're carrying in your blood goes into your lungs and you breathe that carbon dioxide out. Okay? So it would look like that. However, don't forget, we have soda lime, which can be sodium hydroxide or potassium hydroxide. Now, soda lime absorbs carbon dioxide. So if you breathe out into this container, the soda lime will absorb the excess carbon dioxide in the breath that you're breathing out. So immediately you can see what you breathe back in here now has less stuff. There's less volume. And that's what causes that spirometer trace to slowly lose volume. Because each time you breathe in, you're taking out oxygen. You would breathe out carbon dioxide, but that's been absorbed by the soda lime. So essentially, every time you breathe in, you're taking out oxygen. And so the volume, you can see how many circles we've got, is going down each time. Now, what you can do is then work out how much it's gone down. So you can do that, and you can work out that difference, divide it by that time, and that tells you how much oxygen has been consumed, how much oxygen has not gone back in there, how much carbon dioxide has not gone back in there. So the carbon dioxide not going back in there is equivalent to the oxygen you took out. So that tells you how much oxygen has been consumed, and then you can work out over what time periods. You could work out the volume of oxygen that has been absorbed into your blood per second.